All right, so maybe we will slowly get started here. And yeah, welcome back to the Geo-Python course for the second week. And at the moment, we're still collecting some feedback about how things went during week one. So as we get started, if you want to, you're still welcome to send in your feedback about how things went overall. You can also vote here, for instance, if you want to indicate something that's already been supplied to the list here. We'll do this basically every week of the course, that we start out with collecting just some brief feedback about how things went during the first week. Kind of helps us keep an eye on how things are going for you all, and lets us know if there are any issues that are sort of things that haven't come up in Slack or in some other way in the feedback for how things are going. But yeah, for the second week, we will continue on with our Python journey. And maybe just to make things a little bit more visible, we can start by reviewing what feedback is here in this form. Okay, now I guess I can actually see the voting. Sorry, I couldn't see that before. And yeah, it looks like 19 people are already online and visiting the site, so that's good. But basically, during the first week, we kept things pretty simple overall. We did throw quite a lot at you in terms of different websites and different tools that we use in the course, but we didn't really dive deep into doing things in Python in week one. But as noted here, it's good to see people feel like they learned a little bit of Python, some Slack, and maybe a bit of GitHub. We'll continue with GitHub more today, so we'll actually learn how to use GitHub in the way that it's meant to be used. Learned a little basic math and variables, just sort of essential things to get started in Python, how to assign a value to a variable and things like that, how to print things to the screen. And Jupyter notebooks as well, which, just looking at this list alone makes it somewhat clear that we have given you quite a bit to work on here in the first week of the course. So these are things that we will continue to use throughout the course. You'll continue to get more comfortable and more familiar with. And maybe what I'll do here is I'll just one more time paste the link to the poll page into the chat for those who've just joined, in case you want to go there and still provide a bit of feedback about week one. But yeah, basically, everything that we start out with here, we try to not give you things that we're not going to use in the course. So we will use these throughout the course to get more comfortable. And hopefully that will mean that your level of confusion will decrease over time, at least in terms of the things that we're using as technology in the course. Of course, anytime you're learning something new, it's likely that you'll have moments when you're confused. But this looks pretty typical for week one, that you learned a little bit of the basic stuff that we cover. If we have a look now at the other question that was asked, this is basically a question of open feedback, or kind of an open feedback polling question. So any questions, problems, thoughts, whatever. So still not entirely sure how to use GitHub. Well, that's perfectly fine, because we really haven't taught you much about how to use GitHub in the Git way, and we'll do that this week. So hopefully by the end of the lesson today, you have some sense of that. Do we need to fill in and return the lectures somewhere? So no, the notebooks that are provided as part of the lesson materials are things that you can fill in as we go through the lectures and as we go through the lessons online during this time. Or if you listen to the lecture video, you can also follow along and fill in that notebook at the same time. It's essentially a way for you to be doing the same things that we're doing at the same time. And it works best in a classroom where, like, I can have my screen projected up on to some kind of display, and then you can be looking only at your screen, typing in and following along, but it's meant to be there for you to just fill in for your own benefit, to practice what we're doing as we're learning it. So no, you don't need to return the lectures or the lesson notebooks anywhere. And yeah, the question then was also about how the exercises are graded. They are graded most of the time. They will be out of 10 points. So the first exercise is graded pass fail, just because essentially what you have to do is provide us with your GitHub and Slack user information and then fill in this one notebook just to show that everything is working together. But for the remaining 7, well, I guess the remaining 6 exercises, they will be out of 10 points. And so for each week, you'll have 0 out of 10 points for that. And then there is a final exercise that is worth 40 points, if I remember correctly. So that is how things work. And we try, to the extent that's possible, to give you some clear feedback about why points have been deducted and things like that. But sorry, if you have any questions about any of the feedback on the exercises, why you got something wrong or whatever, you're always welcome to ask the course assistants or the course instructors about what has happened. Most of the time, the assistants will be the most knowledgeable ones because they do a lot of the grading of the exercises, but you're also welcome to ask myself or Hovard if you have questions. Looks like there's one more question here in the Zoom chat about where can you find feedback for the exercises. What we will typically do is post feedback in the README file of the exercise for whatever week. I think in week 1, actually, yeah, we have README files for all of the exercises. So normally in your exercise repository, we will add some feedback at the end of the README file. So that would be the place to find it. Of course, exercise 1 is only due today, so we won't have feedback for that for a few days at least. But once we do start providing feedback, you'll find it in your README file in your exercise repository. Are there, let's see, any other questions at this point, either in the Zoom chat or anywhere else? Seems like maybe not for the moment. That's totally fine. So a couple other things before we get started that I wanted to remind you about. One of them is we do have this pre-course survey that I think at least some of you have already filled in. Actually, it looks like 52 people have already filled it in, so that's good. The pre-course survey looks like this. And I'll put the link to it in the Zoom chat, but there's a link in Slack as well. So that's here, pre-course survey. If you haven't filled this out already, it is scheduled to close today at 1 in the afternoon. And it would be very helpful to us if you could fill this in before that time. Essentially, this just allows us to assign you a partner for working in the pair for the exercises in the course more effectively. It allows us to match students up that are in the same course, try to pair people who are more experienced with someone who's a new programmer, and also if you have requests, for instance, like for a partner you want to work with specifically, it allows us to see that and try to pair you up with that person if at all possible. So yeah, if you haven't done it yet, please go and fill in the pre-course survey. You can find a link in the Zoom chat right now or in Slack. You can find it there as well. And sorry, my throat's a little scratchy this morning. So hopefully that resolves itself. In addition to the pre-course survey, yeah, this, I mean, as I mentioned, this is about trying to get you paired up to work together with a partner. And we will inform you of who your partner is by tomorrow, hopefully by the time the first exercise session starts at 12 o'clock. So it takes us a little bit of time just to get all the information processed and pair everybody up. but we'll inform you of who your partner is as soon as possible so that you can get in touch with one another and figure out what your plan is for working on the exercise for this week. So you're welcome to have a look at the exercise for the week once we get to that point, but be aware that you will be working with a partner, and we'll explain a little bit about how that goes later on in the lesson for today. And the only other thing is that there's been a few questions about where exercises are stored. I think when we get to the explanation of the exercise for this week, we can maybe go then through where the exercises are stored. And hopefully then that will allow you to be able to find your repository where your exercise is if you've been confused about where the files are actually stored in GitHub. But yeah, those are the kind of getting started things that I had in mind for today. Are there any questions at this point? All right, I'm not seeing anything at the moment. So that being the case, I'm going to jump then over here to the course webpage. And we are down here in lesson number 2, second week of the course. So what we're going to do is dive into Python a little bit more. This week, we'll become familiar with a few more Python features, including Python lists. That'll be one of the main things we deal with today. And then we'll spend some time talking about version control with Git and how to use github.com in the way that it works with Git. So we'll introduce the idea of what version control is, if it's not familiar, and how it can be used with Git and github.com. And hopefully this will also help you understand why we're using GitHub in general. It might not be clear from the previous week. So the first thing we're going to start out with today is our Python lesson. And for that, you should go here, for instance. I'll try and put myself in like user view to the CSC notebooks. You'll see here the list of all the people who've already opened a notebook, but your view won't quite look like this. It should look similar, but you should go log into the CSC notebooks site and then launch an instance of the Geo-Python 2021 notebook to allow you to follow along with what we're doing in the lesson for today. You don't necessarily have to do this, but it's strongly encouraged because I think it is helpful to do these things together at the same time. If you encounter problems, if you have questions, then of course it's much easier to ask them at the time when you're working through the lesson rather than after the fact. So as noted in the first week, I am still having storage problems with my Python environment on the CSC notebook. So I am going to open this Geo-Python 2021 Lite, but you should open this Geo-Python 2021 for yourselves. This is only because I have storage problems that I'm using the Geo-Python 2021 Lite notebook. And while this opens up, should take just a moment. Let's see. What I can say in general is our Python lesson this week will take us into lists, and let's open this up now so we can see what the lesson actually looks like. And if you're having any issues, just feel free to say something in the Slack chat or in the Zoom chat and let us know that there are problems. But like last week, we're going to go here into the notebooks directory. You should hopefully see that, and you should hopefully see that now you have an L2, lesson number 2 folder in here, and you can double click on that. And the lesson that we're going to use is this Python basic elements lesson, which again, you can double click to open. So this is one of our Jupyter notebooks again. So for those who maybe weren't here the first week, this may be somewhat of a new environment, but we'll review kind of how things work as we go through the lesson. So as mentioned, we are dealing with some basic elements of Python today, starting out with Python lists. And a list is just one type of a structure in the Python programming language that allows you to store a set of values in what's called a collection. So a list is one form of a collection, but it could be a group of different numbers, could be a group of text or other kind of mixture of different things that are all stored together with a single variable name. And in this notebook, there are some cases where we've left in the text already for you to basically just run the cell instead of having to type some of these things in, because it gets a little bit cumbersome with lists. If you have to type in all of these different names, you can't really pay very much attention to what we're talking about as you're just rapidly typing and trying to keep up. So here in the first cell, what we're going to do is create a Python list by just doing Shift Enter. So that will run this cell for station names. And if we then type print and station underscore names and run the cell just by pressing Shift Enter, you can see the output comes out in a form that's a little bit different than what we have seen before. So previously we would have a single value that's printed out to the screen. Now we have a set of different values. So there's 4 of them here for these different stations. And each one is separated by a comma and enclosed in a set of these square brackets. So I'm just trying to highlight the one, but I keep getting both the quotation mark and the bracket. So the square brackets are what allow us to define that something is going to be a list when we create it. So you can see when we store the name or the variable station names, it starts with a square bracket and ends with a square bracket. And the values in between there are separated by commas. Those are the items in the list. And we'll work with this a little bit more. So these will get more familiar to you as we go. So yeah, as mentioned, we could print the values out. This looks very much like exactly what we just typed in with the different station names here. These station names are Meteorological Institute, like the FMI, so Finnish Meteorological Institute observation stations in the Helsinki area. This is just a selection of a few of them. So of course we have Kumpula in here, but there are a few others as well. And these station names are just little text character strings separated by commas when we define this Python list. So we print out the values. It looks like what we put in. That's good. We can check the data type by using the type function. So that'll tell us what kind of data type we have for this variable we've defined called station underscore names. And if you run that cell, again, Shift Enter, or you can go up and press the play button up here if you prefer. What you see here is it comes back as a type list. So this is a built-in data type in Python that can be used to store a collection. And as we would expect, our data type for our variable that contains list values is a list. And just as a reminder here, you can see again, when you create a list that you need to put things enclosed in square brackets to do that. So we had defined individual variable values last time. So if I just to demonstrate here, if I was to go back and just click the plus button here, I've selected the top cell. I'm just going to click the plus to add another cell underneath it. I could define a single value like we did previously. Like I could say something like station ID number. And I don't have any real ID number here, so I'll just put 1, 2, 3, 4, 5, 6. These are typically for these FMI stations a 6-digit number, but I don't actually know what any of the numbers are for these ones here. But if I run that cell, all I'm doing is defining a single value here that's going to be stored in a variable called station ID number. And if I add another cell underneath it by clicking the plus, I can then print out my station ID number. And what I get back here is just 1, 2, 3, 4, 5, 6. And not enclosed in any quotation marks because this is not a character string. This is a numerical value itself. If I check the type of station ID number, which why not? We can do that. If we check type of station ID number, we get back that it's type int, an integer value. So it's a whole number value. That's kind of what we would expect to see in this situation in general. So this is what we had been doing with defining individual values, values to be assigned to a variable. Now we're dealing with lists where we're putting in multiple values here. And this is mostly just to remind you from the week previous how things are different when we have a list. Now, one of the things that is different when dealing with lists than when we were dealing with variables before is that in order to access individual values within a list, we need to use something called an index value or an index number that tells us which position in the list are we trying to access to find one of our data values. So intuitively, you would think I can go here to my station underscore names list that I've defined. And here, if I put in a set of square brackets, the value of number 1, and run this cell, what it should do is it should go to this list called station names and find the value that's in position 1. When I run this, I get Helsinki Kaisaniemi. Now, if we scroll back up here, you'll notice that our list of station names doesn't start with Helsinki Kaisaniemi, but rather starts with Helsinki Hammarja. And Hammarja is the value here that's actually the first one in the list, even though what we've put in here for our number is 1. Now, why is that? Well, that's because the index values and indexing in general in Python starts at 0. So when you want to access the first value in a list, you would need to give station names 0 rather than station names 1. So let's just check that that's the case. We do station underscore names and now 0 and run this cell. Sure enough, Helsinki Hammarja comes up as the station for the first value in the list because our indexing starts with a value of 0. Now, I suppose that all of you know how to get this square bracket character, but if you're using a Finnish, Swedish keyboard, maybe you don't. And so I'll just remind you that if you're a Windows user, you would use Alt and then Shift 8 to do the square bracket. So I'll make another cell here. So if you do Alt Shift 8, no, Alt 8, it will give you the square bracket. So that's like where the parentheses normally would be above the 8. And then Alt 9 would give you the close parentheses in that case, or the close, square bracket. On a Mac, it's option 8, option 9. I think it's Alt. Someone maybe is, okay, yeah. So, or Alt, I don't know what GR is, +8, but I'm not a Windows user, so I have no idea, but hopefully you're familiar with how to generate these kind of square bracket characters if needed. We'll also deal with some curly braces in a little bit later in the lesson. We can show you how to make those as well. I think on sort of English and international, yeah, okay, Alt Control 8, it looks like maybe for Windows. On international English or US English keyboards, I think there is the character already available just to do Shift and then you can, or no, actually there's a separate key for it. So anyway, yeah, hopefully you're not stuck with how to make the square brackets, but you can check the Zoom chat. There's some suggestions there for how to produce the square bracket characters. So index values are something that we're going to be dealing with anytime we want to deal with lists or any other kind of collection variable in Python. And of course, there's some things that are not necessarily intuitive, like the indexing starting at 0. But we're going to have to force ourselves to become familiar with index values because you use them all the time with these kind of data structures. And for this, it can be useful to have some kind of analogy or something you can think of in terms of how index values, how they work. For this, we have come up with the idea of Bill the vending machine. So this is Bill in all of his dark gray glory. And Bill is a vending machine where you can, like any vending machine, put in your money and then select an item to have that item come out of the slot, and then you can enjoy whatever you have selected from the range of items Bill has in stock. This is very much like using an index value to access a variable value in a Python list. So for instance, if you were interested in having a cookie, you would put your money into the slot in Bill, and then you would select the item 1 because that is the first, or the sort of item at position 1 in the list of items in Bill the vending machine. And when you press the 1, then your cookie would drop out of the vending machine slot and you could enjoy it. I think in the past I've given the example of a taco, but that's always a messy one to have fall out of the vending machine. So the cookie is a little bit cleaner in this instance. But the basic idea is that in order to get the item you want, so this could be basically like your variable value that's stored in your list. The item is here, and in order to access it, you have to use this number, this index value, to get the item from that position. And if you've used any kind of larger vending machines, you know that there is some kind of combination of numbers and letters, because you might have things that are in rows and columns. In Python, we don't normally use numbers and letters, but you might have 2 numbers, one that would refer to which column and another that would refer to which row when you're dealing with a list that is more than one dimension. So like a 2-dimensional list, you may have to use 2 index values to access those numbers. But basically, we'll get familiar with this by working with the index values. And when you get confused, you can refer back to and think about Bill, which will hopefully help you to understand how this index value relates to the value of the item itself in a Python list. So yeah, are there any questions at this point about the index values? This is one of the things that's really frustrating in Zoom, is I have really no idea I can't look around the room and see how confused people are. But are there questions at the moment? Or if so, maybe you could put them into the Zoom chat. I'm not really paying attention so much to Slack at the moment. But I guess the idea at least is making some sense here. And we'll continue on and again use some index value stuff as we go through the lesson, and we'll hopefully help keep clarifying your thinking about this as we proceed. So there's a few other things we can do with lists that are helpful. If you want to know how many items are in a list, sometimes you know, sometimes you don't. But the way to find out is you can use a built-in function called len. It will return the length of some collection, or I think if you give a character string, it'll also tell you how many characters are in the string. But we can do len on station names. That's the name of our list we're working with right now. And if you run this, it comes back with 4. And if you remember from what we typed in at the very beginning, we had 4 different FMI stations in our list. So that looks right, as we would expect. So knowing now that we can use this length of, or len function, to tell us how long our list is, you might think that we can do something fun like go here and find out what the last value in our list is by doing station names len station names. So here we're going to give the length of our list, which is the number 4. And then actually I've done my brackets wrong. So this should be a square bracket here. When using an index value, you should be putting it in square brackets, just as we did, if I scroll up here, when we did station names 0. The way to indicate that you're trying to access a value in the list is to use the square brackets rather than parentheses, which would normally be used if you're using a function. So let's just scroll back down here. to what we're doing. So station names, and then in the square brackets, we have len station names. So what this would hopefully do would give us the last value in our list, because our list has 4 items in it. But if you run this, what you'll see is an index error and a message that says list index out of range. Now, if you think about this for just a moment, and probably you've already figured it out, the issue here is that we have 4 items in our list, and the index values are 0, 1, 2, and 3. So the last item in our list is not at index 4, even though there are 4 items in the list. This is the one kind of tricky element to dealing with these Python lists, and the fact that the indexing starts at 0. So when you use this len station names function, you end up in a situation like what we have here, where we have gone outside of the range of values in our list. I could replace this with a 4, for instance, as well, since we know that the len station names is 4, but we get the same result either way. One possibility would be to say, okay, well, since we know everything's going to be 1 less than the number of items in the list. So if I go back here to when I had station names, len station names, I could take this and say, well, I got a solution for this, no problem. I'll just do station names -1. And indeed, that will give us the last item in our list. If we just print out what the list is down here in the cell below. So print station names and run this. We see our 4 station names here. And indeed, the last one is Helsinki Kumpula. And that's the last item in the list. But that's not necessarily a very nice way to have to do things. For one, instead of just having a single number in here like we might like to be able to access a value in one of our lists, we have now this like len station names -1. It just looks kind of clumsy. And as it turns out, there is a trick in Python that's quite helpful to allow you to find the last item in a list. And that is to use station names, square bracket, -1. When you put in a negative index value, what it does is it starts from the bottom of the list and starts going back up the list from the bottom. So station names -1 will take you to the last item in any list. It doesn't matter if there's 100 values, 1,000 values, or whatever. Station names -1, or whatever your list name is, -1, will give you the last item in the list. And similarly, if you know the length of the list, so we could then go station _names and put in here, we know our length of our list is 4 in this case. Let's make that a -4. And if you run that, you see that what is happening indeed is that we're going backwards up the list. So -1 is the last value, -2 would be the second to last, -3 is the third to last, -4 is the fourth to last value in this list, which happens to be the first value in the list as well. So probably you wouldn't want to do this to figure out what the first value is in your list, because of course you can just put in station names 0. But there are some cases where you want to go backwards through a list and process the values in reverse order, and the negative index values allow you to do just that. That said, if you are not being careful, you can still use station names square bracket -5, for example, and get another index error. If you go back from the bottom of your list to a value that is above the first value in the list, then what you get is an index error, again, saying your list index is out of range. It doesn't start over again at the bottom or something like that. It's kind of going, if our list is here, we're going backwards this way. And basically, once you've gone before the first value, then you get this index error. So it's still possible to encounter these kind of index issues with the way things are working in Python. But it's handy to know that you can get the last value, especially with this trick, because then you don't need to know the length of the list at all. You just have a shortcut to get the last value, which in some instances is a very helpful thing. All right, so Now we have a poll question, and I believe it looks like Hovard has kindly already put it up on the screen. I will maybe move my screen here so you can see what we're looking at. So we have a list here of cute animals. So there's bunny, chick, duckling, kitten, and puppy. I'm sorry if I've excluded your favorite cute animal, but this is a pretty good range of popular ones. And the question for you is to now go and vote. Which animal is at index -2? So just take a moment and fill in your responses, and then we'll have a look at the responses once we have a sense. Okay, so 31 people have now responded. Let's have a look. Look at our responses. And what we have here is our cute animal list with 31 out of the 32 responses saying kitten and 1 puppy. And in fact, yes, in this case, what we would expect to see at index -2 is kitten. Sort of a loaded question, like I'm going to ask anything on the internet and not have kitten be the answer. But the point here is that when you go into our list that we're looking at, what you see is we're going to have a negative index, which means we start at the bottom of the list. Value -1 would be puppy, which means that if we're going backwards, -2 would give us kitten. So indeed, it seems everyone is following along and understanding where we are. So very good. Thanks for your responses. So let's continue then with our lesson here about our lists. What we haven't seen at this point is how to modify our values in a list. And so we have seen that we can create a list. We're going to make another type here where we have a list called station types. Again, it starts with a square bracket and ends with a square bracket. And then there's a series of comma separated values inside here. So one of the things about lists that makes them very useful is that they are called mutable, which means you can modify them. And once you've created a list, you can make changes to the values inside the list. Not all data types are like this, but lists are. So if we run this cell, again, everything is already typed in here for you in your notebook. What you should see is a list that comes back saying weather stations, weather stations, weather stations, weather stations. So the 4 stations that we had before are all of a type called a weather station. However, this is not correct. We have one that should actually be a Mario graph. And we can change that value by reassigning the value that is at the index 2 in this case. So if we take our variable list called station types, and we say this value at station types index 2, instead of being equal to what it is now, should be Mario graph or Mario graphs. What this is going to do is reassign the value that is in our list of station types. And I'm just going to go ahead then and print out what that modified list would look like with print station types underneath here. So if I run this cell, indeed, now what we see is weather stations, Mario graphs, weather stations. So as stated, you can modify the values in your list. And this is quite handy. It means working with lists can be a little bit slower than some other data types, but of course, it's nice to be able to modify the values that are there. All right. Now let's continue a little bit more with some additional things about data types and the different kinds of data that can be stored in lists. What we've seen so far is we put some character string values into a list, but we can do more than that. And in order to get started here, we have a set of cells where you can just run the first 5 of them. So I'm just going to do Shift-Enter on the first 5 cells to define these variables. So there's something here called station name, station ID, station lat, station lon. and then station type. This is for the Helsinki Kaivopuisto station, and the station ID, as you can see, is an integer value. The latitude and longitude are floating point values. And then there's two things here for the station name and station type that are character strings. Now, what we can do with these variables that have been defined is we can create a list here called station hel kaivo that contains these 5 variables enclosed in square brackets and separated by commas to create a list of these values for this station Helsinki Kaivopuisto. So again, you can just run this cell, and what you see in the output that gets printed out here is we have Helsinki Kaivopuisto in quotation marks. That's our character string station name. Then we have the station ID, which is just a numerical value, so there's no quotation marks. Then we have our 2 floating point values for the latitude and longitude. And then finally, the value in quotation marks here for the Mario graphs, which is our station type. What have we learned? Well, we've learned, one, that we could put variable values in here to define something that goes inside a list. But secondly, and perhaps more importantly with a Python list, we have learned that the data types in here don't necessarily need to be the same. We have numbers and we have text in the same list, and that's not a problem. So if we check, for instance, some of these data types, we can start out by checking our variable for our station. I guess it was station hel kaivo. If we check the type of that list, sure enough, comes back as type list. No big surprise there. But if we go into the list and we want to check the values and the kinds of data that are in the list at different positions, we can do something like station hel kaivo at index 0. Let's check the data type there. This should be our station name, and we would expect to see that it's a character string. And sure enough, when you run this cell, you get back that the data type is str for character string. No surprise. Now I'm going to copy this just so I don't have to type it a second time here, and then edit the 0 to check what the type is of the value that's at position 1 or index 1 in our list. And now we have an integer value. Sure enough, our station ID is an integer value. And finally, just for the sake of it, if we check at index 2 what the data type is, we get back that it's a type float. So that's a floating point number, and that's exactly what we would expect for our station latitude in this case, as we defined it with a decimal point in the definition of the value. So we can have mixtures of values, and if we want to check what kinds of data we have in the list, we can then just go and use the index values to check individual data types. All right, so let's do a couple more things here. First off, we can add and remove values from our Python list. We've seen that we can modify them, but if you want to add something or remove it from a Python list, that's also possible. They are very flexible kind of data. So if we go back and just print out our station names just to remember what we were looking at, we could do station underscore names. And sure enough, here's our 4 stations we've been dealing with up to this point. If we want to remove a value, we can use an operator called del. So we just say del for delete, and then some value within our list. Please pay attention here and don't del station names, but make sure you do station names and then a single value. So we'll take the value at index 0 and delete that. If you del the whole station names, you're going to delete the whole list. This will remove a value from the list so that if we print out what's in station names now, what you can see is that we have Helsinki Kaisaniemi, Helsinki Kaivopuisto, and Helsinki Kumpula. Our Harmaja station has been deleted from our Python list. No big surprise there. If you want to add values to a list, it's a little bit different. But the typical way that you would do it would be to use something like station underscore names dot append. And append will add a value to the end of the list. And so then you would give the value that you want to append. In this case, it's suggested here to give Helsinki Lighthouse. So we'll follow that example. And we can do another one for station names.append. And we'll do Helsinki Malmi Airfield. I don't know whether this station's still operational. I think the airport in Malmi has perhaps closed, but maybe the station's still working. So this append function will take a Python list and add values to the end of it. So when we run this cell, we're going to add some values. And if we print out what station names looks like now, you can now see that we have Kaisaniemi, Kaivopuisto, Kumpula, Lighthouse, and Malmi Airfield for our station name. So yes, indeed, we did add the 2 additional values there. This is not the only way to add things to a Python list. So I will just briefly show you one other example that can be helpful. Let's start out by defining a new list, and I haven't really planned this. So let's go with something that's, I don't know, somewhat interesting. How about dog names? Maybe not that interesting because I think I use this example a lot. So we can make a new list called dog names, and we'll type in some typical Rover, I don't know, Woofy. I think I used Woofy last time. And how about the dog nobody wants, Bitey? So we create this dog names list like this. And then we'll make another list here called more dog names. And now I've put myself in a position I need to come up with some additional dog names. So how about Spot? That's a nice one. And how about Mr. Dog? And let's go with Sleepy. I don't know. Nobody names their dogs these things, but whatever. So we have these 2 lists like this. And if I just run the cell, we'll define these 2 lists and they'll be stored in memory. Can add another cell underneath here just by clicking the plus. And if we wanted to have our big dog list or dog, let's call it dog name list. We can basically add these 2 things directly together. So you can use the mathematical plus operation to take one list and add it to another list. Depending on what you're doing, this can be a more effective way to deal with things than doing the append. Like especially if you have a list with 500 values and another list with 500 values, you probably don't want to go through and append all of the values to the other list. That's kind of a slow operation, but you can just add them together. So you could do, for instance, here, dog names plus more dog names. And then after that, let's go ahead and just print out what our dog name list contains. So when I run this, it's going to make a new list called dog name list. That is the values from dog names plus the values from more dog names. And sure enough, when I print this out, we now have one list with all 6 of our dogs' names in it. So that's just for your own benefit, because there are several different ways you can kind of approach these problems. Sometimes appending makes more sense. Sometimes it's better just to add 2 lists together. And this was just to kind of show you that that is a possibility for adding multiple values to a Python list at the same time. Generally speaking, list.append is slow, especially as lists get bigger and bigger, because every time it basically needs to take what was in the old list, create a copy of it in memory that's 1 bigger, and then store the additional value. So it's a kind of slow operation. All right. So what we have seen, for instance, in our example is that we can use append to add values to a Python list. But not all values or not all variables are able to have things appended to them. So if we looked at the list of our station names, and we wanted to know how long it was, we could say like make a variable called station name length. And that's equal to len of station underscore names. So remember, the len function is just going to tell us how many values are in station names. And then we're just going to store that in a variable called station name length. I'm going to copy that. So run the cell, that defines the variable. And then we can print out station name length. And we get back a value of 5. We had 4 previously, but then in our example, we deleted 1 and added 2, so now we have 5. Makes sense. If we check the type of station name length, what you can see is it's a type integer, no surprise there. And because it's type integer, if we try to do something like station name length dot append, and then, I don't know, some number, whatever, and run this, what you're going to do is get what's showing up in Python as an attribute error. And it says int object has no attribute, append. This is something that we won't talk about a great deal during the course, but we'll talk about this a little bit. Python is an object-oriented programming language, if that means anything to you. Essentially, what it means is that the data types that exist in Python have a certain set of operations they can perform on themselves. So a Python list can do a function called .append that is built in to the list data type. It means you can add values to a Python list using this append function. An integer does not have any way to append a value. It doesn't really make any sense to try to append a value, but this kind of thing does come up from time to time in the exercises you're working on. So be aware, if you get something like an attribute error, it's most likely because you're trying to do something to a data type that doesn't have that built-in function available to it. So an integer, for instance, won't be able to append anything, but we'll encounter other data types where appending is possible later on in the course. And of course, many other things can be done to different kinds of data that we're going to interact with in later weeks during the course. So this is just kind of a word of warning that you may encounter problems. We've got a few other things we can do with lists that are useful. One of them is that there is a built-in function for a list called count that will allow you to check how many instances of a certain item are within a list. So if we did station names dot count, and then in here we put in Helsinki cupola, what this will do is it will tell us how many times does the value Helsinki cupola occur in our station names list. If you have some operation you're doing where you want to make sure that you only have one listing of a certain value in your Python list, this is one way that you could check it, is to say, okay, well, this better equal 1. Otherwise, we've got duplicates of our station names, which is maybe not what we want. So when you run this, sure enough, what we see is station names count of Helsinki cupola gives us a value of 1. That's because it's only in the list one time. If we did the same thing with something where there were multiple values that were the same in the list, then we would expect to see however many values that is come back here in the dot count. There's also a function called .index that allows you to figure out what the index value is of a value inside of a Python list. So if you want to modify specifically the Helsinki cupola, the list value where Helsinki cupola is, you would want to do station names .index. And again, you want to put in some value that's in the list. So in this case, Helsinki cupola. When you run this, what it does is it tells us, okay, yes, we know from our .count that Helsinki cupola is in the station names one time. And the index position that it's at is index number 2. Now, if we just scroll back up here a little bit, just for a second, to our station names list, index 2 would be the 1, 2, 3. So third value in the list, 1, 2, 3. Sure enough, there's Helsinki Kumpula, as we would expect. So again, this can be useful if you're trying to say, oh, I want to modify the value. You know, if you see there's a typo or something, you can get the index of where this value is in your list and then modify that value accordingly. The last two things that are given here are very useful, but things that should be used with a bit of caution. So there's a reverse function or reverse method that will allow you to take items in the list and reverse it. So if we did station names dot reverse and run this and then print out what station names looks like. We now have our list in reverse order. So the last value is now Kaisaniemi, then starting with Malmi Airfield, just like what we would expect. The reason you need to be a little bit careful with things here is that the way this works, when you run this station names.reverse, you don't get any output written to the screen. It actually outputs a value of none in Python. So if you were to assign your station names.reverse to a variable or to, even worse, to itself. So I will demonstrate this for the purpose of learning. This is not something I recommend doing. So if we take station names and say station names equals station names.reverse, which might seem like an intuitive thing to do, if you run this, and I'm going to copy this output text here first. If you run this and then you print out station names, you get back none. So this function returns a value of none. It reverses the values in the item or values in the list when you run the command, but you don't want to assign the output to the variable that or the list that you're trying to reverse, because basically what it does is delete your list. So since I've just deleted the list, I'm going to take what we had before from our output and just restore that so that now our station names is the same way it was previously. But yeah, be careful with this dot reverse thing, that you don't assign the output to a variable. Same thing goes actually for the next function here for dot sort. There is a list dot sort function. So if we did station names dot sort, this will sort the items in our list. And if we print this out, station names, we now see Kaisaniemi, Kaivopuisto, Kumpula, Malmi, and then Lighthouse. So what this has done is put things in alphabetical order, with the notable exception that the Helsinki Lighthouse with the lowercase l, in the order of characters in the computer, lowercase values always follow the uppercase equivalents. So that's why Lighthouse is after Malmi Airfield, whereas if any of us were to alphabetize these, we would probably list Lighthouse first. But since in this case it starts with a lowercase l, it's a later character in the order of characters in the computer's memory. So that's just one thing to be aware of with the lists. All right, so I have one more topic to cover before we are scheduled to take a little break. And this topic in this case is essentially about getting our different data types to work together nicely. So we have already defined earlier in the lesson some variables called station name, station ID, and station lat. You might remember that this was a character string and a integer value and a floating point value. We can just check those all by typing type station name. Note this is not station names, which is our list, but just station name, which I think is I think it was the Kaisaniemi or maybe Kaivopuisto. I think it's Kaivopuisto actually. So yes, type for our station name is a character string. Type for the station ID should be a full whole number integer value. Yes, it is. And then type for station underscore lat should be a floating point number. And sure enough, it is a floating point number. The reason this matters is because some data types work nicely together. If you want to add together an integer and a floating point number, Python will do that without a problem. It's like, hey, two numbers, no problem. But if you take, for instance, the station name and try to add to it the station ID, you're going to get an error message. The reason for this is you're getting a type error, which is basically saying the data types you're trying to use are not compatible with one another with the operation you're trying to complete. So it's trying to concatenate or add together a character string with another variable, but it says I can't concatenate a string with an integer value. It has to be another string in order for me to put these two things together. Of course, that doesn't mean you can't find a way to get your numbers and text to play nicely together, but it just means that you have to do some additional steps in order to make that happen. So adding the number together and adding some character string together, Python's just not sure what you're actually trying to do. We need to be a little bit more explicit about what we're trying to do. So we can take our station ID and define a new variable called station ID str. That's going to indicate that this is a character string. And we will take our station ID and use a function called str to convert it from a number to a character string. So this is our station underscore ID. So the string str function converts some number to a character string value. And then we can confirm the data type has changed. We can check its type with the type function. So if we look at type of station ID str, sure enough, it is typed string. And if we print out its value, we can see, for instance, that it should be now enclosed in a set of quotation marks. So if we just look at our station ID str and run the cell, sure enough, we have our number, but our number is now enclosed in quotation marks, which indicates it's a character string and not a whole number. All right, so now we have an opportunity for another poll question. And this will give you a little bit of a break from me speaking for just a moment. I do have, a last little thing here about getting our data to play nicely together, but that should be pretty short. So let's take a look here at our poll question. And there's two of them. You can see them both on the screen now. And the first is select the output you would expect to see when you execute the following. So print station ID plus station ln. So what would you expect to see when you do this operation? And secondly, what would you expect to see when you print station name plus station ID str? So you can choose one of these options to vote for it, and we'll have a look at the output from the voting in just a moment. All right, we are up to 25 responses. So let's see, what do people think? All right, we've got a little bit of variation here, so this is nice. So the output you would expect to see when you execute the following: print station ID plus station ln. So station ID, do you remember this is a variable that is of type integer? All right, station ID underscore str was our string value, character string, but this is just an integer value. Station ln, also an integer value. And as it turns out, those two are perfectly happy to play nicely together. So when you try to add them together, what you'll see is not a type error, but you'll see one of the options down here below. As it turns out, what this will do is it will just do the mathematical operation of adding these two numbers together. So the most popular option here, this 132,334.96, is indeed what you would expect to see as the output here, because you're basically just adding these two numbers together, and Python is perfectly happy to do that. So this looks to be no problem here. These are two data types that, again, they play nicely together. Let's have a look at the other option. So that's our question 2.4, which was about now adding together station name plus station ID str. Thanks to the 28 of you who have responded here. What would you expect to see in this case? So here we have station name, which is a character string, and station ID str, which is also a character string. These two are also compatible data types. So when you add the two of them together, what you'll see is basically you just add the two character strings together back to back, or whatever you want to think about it as. So station name is Helsinki Kaivopuisto. The station ID str is this set of numbers here. So yes, the output you would expect to see is exactly what is shown here in the kind of most popular response, which is the station name itself. And then right after that, the character string for the station ID. Okay, so overall, I think it seems like everybody's on top of things, so that's good news. And we'll return to the lesson here for just a moment before we do this promised break. So we can combine our text along with numbers. There's a sort of approach for doing this that's relatively straightforward. We have things like our station ID and our station name that we might want to add together. So we could make a variable here called station ID and, or station, sorry, name and ID. And we can set that equal to our station name, which is a character string, plus, we'll put this colon character and the space in quotation marks, and then plus str of our station ID. We could also use our other variable, station ID underscore str, but we'll just do it like this for the purposes of demonstrating things. So now we have station name and ID. Here's a character string. We're going to add to it another character string. You've just seen that you can put two character strings together and it just concatenates. So it just adds to the end of the first one. And then we're going to, again, add to the end of it with our station ID here, so that when we print this out, our station name and, if I can get the underscore to play along, station name and ID, right? I do have to run the cell before I try to print its contents out. You now see Helsinki Kaivopuisto, colon, space, and then this station name, or sorry, station ID that's been converted to a character string. So that's one way in which we can get text and numbers to play together nicely. That is to use this str function to convert our values to a character string and then add it to another character string. But there are more options here. And this is a slightly more advanced topic. I'm just going to briefly introduce this because you'll see it and you may want to do this yourself when working with text and numbers. But this is essentially about the topic of how to format text and how to format numbers when you're trying to get text and numbers to work together. So we have an example of a situation where we have a temperature value that's associated with a station name and a station ID. We want to get all of these things together in nicely formatted output. And in Python, it turns out there's three different ways in which you can do this. There are these things called F strings, which is what we'll demonstrate. And then there are two older methods. One is called .format, and the other is using this % operator that we don't really recommend, but we show as examples here on the course page, just because you're very likely to see them when you start looking around at Python codes online, and you may be kind of wondering how they work. But F strings are the thing. They're the new kind of way to do formatting of output, where you have combination of variable values with different data types, and you want to get them all together into a nice string. And they're relatively intuitive to use as well. So we'll jump down here to our F string formatting example. I'll show you this, tell you how it works, and then I think we'll take a break just after that. So we have here a variable called temp that we can just run this cell to define. You can see it's 18.56789.876. So it has lots of decimal places. And if you're going to print out some text to the screen, you might say, I don't really want to put, 7 or 8 decimal places of output for this temperature in my output, but I want to truncate it at 2 decimal places. We can do that using our F string in the following way. So we have here, a variable that we'll define called info_text. This is just some variable name. And the key to an F string is we start with the character F, and then we have quotation marks that follow it. It can be single or double quotes. I guess I'll use double just because we haven't been doing it. Now we have within the quotation marks a character string. So we could say the temperature at, and then here we're going to put in a variable name to say our station name that we want to show the temperature at. Now for me on a Mac, I'm going to do Option Shift 8 to make one of these curly braces, or an Option Shift 9 to make the kind of closing pair for it. I suppose looking at what was suggested in the chat earlier for the Windows users, I suppose this is going to be Shift Alt Control 8, maybe. I don't know if someone can confirm that in the Zoom chat. That would be good. I can't remember for the Windows keyboard layout how exactly it goes. But it looks like there's Alt-GR+7 or 0 on Windows. Okay, that's right. So the 7 and 0 on the outside of the 8 and 9 has the curly braces. So thank you, Emma, for that. So yeah, you've got to make your curly braces, and then inside the curly braces, we're going to put a variable name. In this case, so the temperature at station name is what we'll put inside here. So we'll say the temperature at station name station, and then we'll put ID : and again, we're going to put another variable value in here called station ID. So the temperature at station name, whatever, station ID, and then we're going to list the ID inside there, is, and then we'll put another third set of curly braces and another variable name here. But the difference this time is we're going to say temp and then : point to F. I'll explain what this means in just a second, and then Celsius, period. This is our F string. So what we have here inside the quotation marks is basically a character string with some variable values inside here that are going to be replaced by their equivalent text when we produce the output here. The one exception is with the number, but we'll see that in just a second. So we have our info text that we've stored, and if we print out what info text has in it, you see the temperature at Helsinki Kaivopuisto, so that is our station name, station ID, there's our station ID, is 18.57 Celsius. So you can see here what's happened is we've taken our variable value temp, but we've given a formatting string or sort of additional formatting specifier that says do something after the colon to this number value. In this case, by listing 0.2, we say you should use 2 decimal places, and then the F says you should display this number as a decimal floating point value. If we wanted to change the formatting, we could. We could say 0.2E, which would display the value as scientific notation. If I run these 2 cells again, then I get what is arguably less easy to understand output. But the temperature at Helsinki Kaivopuisto station is 1.86 E, which is the shorthand notation for times 10 to the power 1 Celsius. So what you list here, if it's E, if it's some other kind of formatting thing here, will change the way in which the numbers are displayed. And the way to interpret this is sort of diagrammed here underneath the F string statement. So they always start with the character F, hence the name. And that's the most important thing to not forget to include there is F at the start, and it's right outside of the quotation marks. So F and then quotation marks. Then the contents you want to format are within the quotation marks, where if you want to put variable values in there, you enclose them in curly braces. And if you want to add some kind of formatting specifier, like if you want to round your numbers to a certain precision, then you should do that by indicating something like 0.2 or 0.4 F. And in that way, the numbers will be rounded as they are displayed. So you can find a little bit more information down there about the F strings underneath here. So it does show you that F will use decimal values, E will be scientific notation, percent will give you a value as a percentage, and I think there may even be a few other possibilities for how you could format the numbers there. It's possible to list how many spaces total should be used to display the number, how many kind of how wide the number should be, and if you want leading zeros and things like that. So the question here, could we do that from a list? So I suppose this is a question about if we wanted to have in place of one of these variable values here, a variable value from a list. I hope I'm understanding that correctly, but certainly you could. I don't remember where our Helsinki Kaivopuisto station was in our list, but we could put in station names, I don't know, 1, and say the temperature at station names 1, station ID blah, 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 is this Celsius. You can run this where you put in here an individual value from a list and output okay, it did turn out to be Helsinki Kaivopuisto. And just to prove you I'm not lying, if we change the index value, then we get a different station, Helsinki Kumpula in this case. You can do things like that where you're dealing with individual values from a list. I don't think it's going to be happy if you try to give the whole list here. I guess it will format and put the list in there. The output doesn't look very good, but it is possible to do that. Of course, if you're dealing with a sort of print statement like this, most probably what you want to be doing is putting in one of the individual stations and not the entire list itself. But when we'll learn in future weeks, we can do things like go through all of our list items and process them individually. So you could have a whole series of print statements that goes and prints out each value from your list. And if there were corresponding lists of station IDs and temperatures, you could then print out those values as well. That is something we'll cover, I think, already next week, if I'm not mistaken. So yeah, good question. So just to conclude here before we take our little break, there are these other possibilities. So there's the dot format method that looks something like this. It looks a bit similar to an F string. There's no F out in front, but you can see things that are enclosed in curly braces like we had before. In this instance, I've shown you what I think is the most common way that I use the dot format statements, which is to basically have these 0, 1, and 2 in the curly braces that refer to a list of variable values that are given in a dot format list after this definition of our info text. But if you run this cell, you'll see it gives exactly the same output as we had before. And the third option here is the kind of much older approach for formatting character strings in Python. That's the percent operator. And so here we have in places the temperature at %s, ID %s is %.2f. And then there's a percent sign here and a list of variable values there. To me, this is the least intuitive and kind of most error prone. So we definitely would recommend using the F string approach for formatting your text and numbers together. There's a couple other links at the bottom here if you want to get some more information about this, but in essence, if you can kind of have a look at this diagram for how to use an F string, very probably you're going to want to do that at some point in the exercises or in other parts of the course. So that would be a good thing just to be aware of in terms of the possibilities for how to format numbers and text together. Okay, so it's 10:38 now. I've been talking for a while, and I would very much imagine that you're looking forward to having a little break from that. So why don't we do 12 minutes So we'll come back at 10:50. And when we come back, we'll be talking about Git and GitHub and how to interact with GitHub using some of the tools that we have available to us in Jupyter Notebooks. So unless there are any urgent questions, if there are questions you would like us to discuss when we come back from the break, you can add them in the chat. But let's take a break and come back in about 10 or 12 minutes.